Hello everyone, thank you for your time today. We're going to talk about Azure and service principals. The idea of the talk is to show how excessive privileges can be abused in real-world scenarios and environments. The goal is to raise a little bit the awareness around enterprise applications so you can either detect them and mitigate them or use them on real-life scenarios. Oh, and one quick disclaimer, the opinions are our own, it doesn't represent our employers. So, who am I? I'm Gyftos. I'm a senior cybersecurity consultant. I've been working mostly on red teams, purple teams, Azure engagements, AWS, and DevOps. Nikos?
Hello everyone, I'm Nikos. I'm a senior offensive security consultant. I have a few certifications. I have experience in ICAST and TiberEU TLPTs, and I'm proudly member of CFP board of Offensive X. And this is my favorite number, 19, and Nick Vourdas is my handle name. You can find me on social media.
Okay, so a quick overview of the content for today. We're going to talk a little bit at the beginning about the security landscape that exists in modern environments. We're going to showcase how defenders think and how attackers think. Then we're going to show 4 different scenarios, and we're going to do a quick demo of a tool that we created to help people identify those excessive privileges. And we'll end the talk with some detections, recommendations, and Q&A section. Okay? So starting off with the existing landscape. We noticed that organizations become more aware about security around users. They try to enforce more controls around conditional access policy, using trusted device to authenticate, using geofencing, and also risky sign-in implementations. And that's all good. But on modern environments, users are not the only entity that has privileges, especially on Azure. We see a lot of applications being used, in particular enterprise applications, and those are tied with service principals. For those who don't know, when you create an enterprise application on Azure, that is tied with certain permissions, and those permissions represent service principals. The applications are being used for several different reasons on cloud environments, including automation, scalability, and seamless integrations. So, we see a dominance of those applications. They are being used in DevOps environments, they're being used for backups, they're being used for device and user management. And we see a great adoption of those applications on modern and corporate environments. So the question is, how are those being secured and what kind of privileges those have? Because if we're not monitoring them well enough or we don't secure them, following the least privilege principle, how do we know we can use them on our environments? On this slide, we're going to visualize how modern environments, or like a baseline of environments, looks like. We have an internal environment with the Active Directory. We have a cloud environment with a Microsoft Entra ID that acts as the identity service provider, and then we have applications either that are built within the organization or from external third-party vendors. And as you can see here, we have a lot of arrows going back and forth in that environment. All those arrows represent actions performed by service principals. That can be authentication, that can be syncing, authorization, and executing different workflows. So at the back end of this whole thing, enterprise applications are doing all those actions for us. So we want to give some examples here. Organizations might leverage PAM solutions for vendors or custom-made to narrow down the permissions that users have, but that comes with a risk here. As we can see on the screenshot here, we have highlighted some permissions like Application.ReadWrite, AppRoleAssignment.ReadWrite. Those are highly privileged permissions that a lot of talks about cloud talk already. We're going to showcase some additional permissions and how those can be abused from real-world examples. At this point, we wanted to highlight the research that has been done already in the area. I shout out to major players in the field like DirkJam, research from SecureWorks, from Mandiant and SpectreOps, of course. All those showcase how service principals can be abused, and we based our research on that to take it a step further and showcase some additional attack vectors. So now Nikos will take the stage for a second.
Hello. You know that we are from Greece. So in Greece we have a tall mountain named Olympus. So before 2 weeks, me and Marios, we climbed to Olympus. And according to mythology, they're living the 12 Greek gods. So as you can see from the picture, you can see the clouds. So we tried to discuss about cloud security with 12 gods.
Well, Nikos wanted to talk with Zeus, by the way.
Yeah, it was very interesting. I think Zeus learned a lot from our presentation. So what we bring to the table today, we will show how the enterprise applications are very risky and they are targeted for real world scenarios. We'll show new post-exploitation techniques and all are based for our previous engagements. So, at this point, a service principal of in-house or enterprise or third-party application follows the list of privileges. No way, and we'll show this today. So we developed 4 based real-world scenarios. Some of them will be for you familiar. Some of them will be new. We tried to focus in many fields like DevOps, in-tune LOL apps application, or something similar that you have a custom owner to take Azure full access. So, let's go for the first scenario. The first scenario is focusing from an app owner of enterprise application to Azure full access. For this scenario, we'll split it to 2 attack paths. One focuses to Azure resources and one focuses to Entra ID. These attack paths shows multiple steps that you can compromise a lot of service principals. Fun fact, the specific one is very similar of my last engagement. We have a guy here, we have a user here named Labros Kotlitsas. It's just a user, it's a custom user, not something special like global admin or with any other sensitive role. Also, we see that from Bloodhound, this user sync on premise, so in order to compromise this user, you have 2 options, directly to try a phishing campaign and steal the access token, and the second one to compromise the on-premise environment and try to jump, to pivot on the cloud. Let's assume that we have already compromised this user, okay, and we see that this user, it's the owner of this enterprise application, PAM Manager, and as you can see, this enterprise application, it has Application.ReadWrite.All. So what is this? You can modify any other service principal without any administration approval. So far we have seen this year how many times?
A few.
So this is the attack path that we will follow. We have the owner, I'm the owner, I will try to connect to the application, and then I will try to change the credentials of service principal, and then to use Application.ReadWrite.All to compromise the other service principal. I think it's very simple. So we'll log in, because we are the owner of application, we can create a new credentials, as you can see. From the portal we can confirm that we change the credentials, and then using the new credentials we can log in as service principal, and then we can find the other service principal, and by using Application.ReadWrite.All, we perform the same attack. We create new credentials. Now we have compromised successfully subscription manager. So at this point, 9 to 10 times so far, this attack path ends like this: user access administrator or contributor. User access administrator, if you don't know, it's you can add any user to any to the subscription that is affected. For this scenario, we choose to use contributor. The contributor, it's a role that you can delete everything, you can do anything you want in Azure resources. So, at this point, we saw that attack path affected to Azure resources. Let's focus a little bit to Entra ID. For this attack path, it's pretty similar. We saw that, again, the owner can change the credentials of the service principal, and then using RoleManagement.ReadWrite.Directory, we can add ourselves or any user as a global admin. We'll assume that we will not reperform the previous steps. It's the same thing. We'll connect to Service Principal, and then we'll try to connect to with Graph API and use and add our Service Principal as a global admin. As you can see, this is the proof from the portal. So this was the basic first scenario. Let's go to the second scenario. The main scope of this scenario is to show how in a teaming engagement you can use Service Principal to blend in and read emails of other users. So for this scenario, we have a conditional access policy that we can see that this is a user CO. But for this conditional access policy, there is an exclusion. Something that we have seen so far a lot of times in our engagements. A lot of companies, they use an exclusion when you work from office to don't require MFA. So we can see that there is a service principal named email protection, and this service principal has the following roles: email read, email read write. And we have a user, Nikos who is cloud application administrator. We can compromise this user again, like if we have compromised already on premise. We can pivot back if this user is hybrid. So at this point, we saw that I said we created Kerberos ticket, and then with this Kerberos ticket, we take the access token to connect with the Graph API. So in this way, you already know that you can pivot from on-premise to cloud. So let's see that this is the application. Because we are application administrator, cloud application administrator, we can edit any service principal. So we connect again with Graph API. We can verify the permission here, as we already said before. And then we can focus that, okay, let's target the CO, an executive, or CTO, a CFO. And we see that there is a sensitive information attached, okay, via the subject. This is for scenario, okay? And we see that there is file attached. So converting bytes back to ASCII, we can read the content of the file. If you want.
Yeah. So the first two scenarios talked about kind of known attack vectors, but we showed cases how they can be used in real scenarios from different experience we had in the past. The next two scenarios will focus more on something kind of relatively new, not so very well documented attack vectors. So the next scenario is code execution via Intune low applications. There are 4 steps in the process here. We're going to abuse a device management application permission, API permission. We're going to create a line of business application, or LOB. In Intune, we're going to deploy this application on Windows hosts, and then we're going to see that those applications can run on systems, on Intune enrolled systems, as a system and authority system. So that could be a way for you to escalate privileges or move lateral from cloud to on-premise and establish persistence. So what is new about this technique here? The articles that exist up to this point focus more on the device management configuration read-write-all. There are a lot of ways and articles to exploit those, but during our research we didn't find a lot of documentation regarding the device management apps read-write-all. And as you can see here, the documentation states that you can read-write Microsoft Intune applications. So the question is, what are those applications and how can create one and deploy one? Again, going back to documentation, we see several types of applications, and what caught our eye was the line of business application type. It says that it's a custom application where you can provide your own installation file. So I guess that would be fun. We have an enterprise application then, Intune Manager, that has this specific permission, the device management apps read-write-all. Going back to the documentation about this specific API permission, we see that the application can read and write properties and group assignments, but it doesn't talk a lot about the fact that you can upload applications and what kind of code you can put in those. Apparently, you can do any kind of application you want, and you can deploy it on all devices, either if they are Windows workstations, mobile devices, but in our scenario for the proof of concept, we're going to focus on Windows applications. We have a low privilege user that is assigned the owner. We're not going to go again how you can get there. We take it as granted as a starting step here. But as we said earlier, the owner can create a secret for the application. So after we have the secret, we can use PowerShell or any other tool you want or language and get a graph access token for the application. And at this point, you're impersonating a service principal in a cloud environment. So what files can we upload? That's the first step we need to figure out. Apparently, we need to prepare the application that we want to upload, and based on Microsoft, we need to use a tool called Content Prep Tool, which before my research I've never heard before. And it says in particular that we can convert applications in .intune win format. So because I was not very familiar with that, I had to do some research on how we can do that. And apparently Microsoft has an open source tool that helps you streamline this whole process. First of all, we're going to create our payload. For the proof of concept, we're going to just do a whoami under the C directory. We're going to make it an exe, and then we're going to use the Microsoft tool, the Intune WinApp util, to pack our application in the Intune Win format. The tool is very straightforward to use. We need to provide a source folder and an output folder. And given the source files that we want to use, in our case the exe that we wanted to pack, we can run the tool and it will generate the payload.intune win file. So at this point we have created a simple proof of concept. We have the file in the format that Intune wants you to have the file, so you can upload it on the portal and then keep going with your attack. So let's upload the payload. But wait, how do we upload the payload on the portal? Microsoft has documentation about how to do it from the UI. It doesn't have though documentation on how to do it in any other different way, because what happens if you're in a real engagement and you cannot use, you cannot use the Intune Admin Center? We did some research, and trying to interact directly with APIs was not very useful. We're running a lot of errors. So we found a project on GitHub that was created for that sole purpose. The project is the MS Endpoint Manager Intune Win32 app, and that has a list of modules that can help you properly upload the file that you want on Intune, and then you can even make the assignment to whichever group you want. So we download the module, we look a little bit on the modules it has, and we see that they have one named Add Intune Win32 application. So I guess this is what we're going for. Now, the tool has a little bit more configuration to be set up for using it correctly, we need to provide our payload. We need to give some detection rules, installation and uninstall commands, as well as detection rules and requirement rules. We need to specify which operating systems we want it to be installed at and the minimum version. But after figuring out all those details, as you can see at the bottom of the screenshot here, the application was successfully created. Next step is to decide where we want to deploy it. In modern environments, usually the Intune and Roll devices will be on Entra ID groups, so it's kind of straightforward, but you could also assign it to a specific user or device. Let's say you find a user you want to compromise, you can target that particular user instead of the whole environment. Well, if you get the whole environment, you get more cells, but still. So we have the object ID, and the same PowerShell tool has another module named Intune Win 32 app assign group. So on this module, we need to provide some information such as the assignment group and also the application ID, and that's the application ID of the app you uploaded on the portal. You get it on the output of the previous command. Another thing to note here is that the intent is very important. We need to put it to required. Otherwise, the user would need to manually go and install it. But if you have it as required, the next time the workstation or the device tries to sync with Intune, it will enforce the download and execute your payloads. As we can see, we were successful in assigning the Win32 app. And so far, we have leveraged only this one permission that we talked at the beginning, the device management app, ReadWrite.All. If we look on the portal, we see that the application is waiting to be installed. So when the user goes online or the sync happens, which I believe it's every 30 minutes or over a reboot, the device will try to pull any new applications that Intune requires you to install. And after the application installs, on the application section, it says enforcement complete and the last sync date. So looking back at the portal, we see now that the application is installed. So let's go back to the device and see if the file was actually written with what kind of permissions. We see a WMI under the C directory. Okay, good so far. And if we look at the privileges, is empty authority system. So that is a powerful way to either move lateral or establish persistence or even escalate privileges on a workstation or any device that is enrolled in Intune. Now off to another scenario about Azure DevOps and how we can leverage an Azure DevOps administrator to compromise a service principal and pivot from the DevOps environment to either Entra or subscriptions. In this case, we're going to focus on subscription pivoting because a lot of times in real-world scenarios, the DevOps pipelines and the environment is integrated with automations and deployments in the client's environments, and that requires resources on Azure. Again, so far we've talked about 3 scenarios where a user was either owner or a cloud application administrator. So you will ask me, okay, this is the only way? Not always. Being an owner or a cloud application administrator is not always your starting point, depending on how the organizations are set up. Each environment is unique, and we always need to adapt our mindset on how the environments work. Let's say we have a company that develops their own software or tools, and they use Azure DevOps. Obviously, the DevOps is an important part of their day-to-day operations, so probably they have more privileges assigned on users or applications on the DevOps environment than a company that barely uses those features. Looking at Microsoft documentation, they have assigned the word privilege on certain roles, built-in roles in their environment, and as we can see, the Azure DevOps Administrator is not assigned a privilege role. However, this changes from case to case. Because of the definition of Microsoft doesn't consider it privileged, again, if an environment is using the DevOps organizations, maybe organizations need to consider that highly privileged depending on how this is being used on their environment. So we can understand that this is kind of a dynamic thing that we cannot predefine if it's privileged or not. Microsoft might not consider it, but under certain circumstances that we're gonna showcase here, it can be very useful for attackers to abuse. Now, Azure DevOps Administrator, apart from the rest of the description here, it mentions that they can take over orphaned DevOps organizations. But what is an orphaned DevOps organization? Apparently, when the owner of the DevOps org is inactive or all the collection administrators are inactive, this organization becomes orphaned. And what does that mean? It means that it doesn't have an owner, and the ownership can be transferred to another user or entity in the environment as long as that entity has the Azure DevOps Administrator. So in that case, we're gonna start from having a user, Jedi Master in this case, who is an owner of the RebelOps organization. And that user, for some reason, is deleted. In real-world scenarios and environments, people might leave an organization, might change their role, and at some point, the user might be inactive or deleted. If that is the only owner in the application, in the organization, then that org will become orphaned. Then we have another user who has been assigned the Azure DevOps Administrator. So we're gonna showcase how this user can take ownership of the previous org and how it can leverage information and default configurations to pivot on the Azure subscription. However, when we access the DevOps organization homepage, we don't see any organizations here. That happens because Azure DevOps organizations do not appear even if you have an Azure DevOps Administrator. Your organization will show only to the persons who are owners or have assigned some permissions on those. So even if we have that privileged role, we cannot see any other existing organizations within the tenant. So options usually, in that case, that we can leverage, or another attack vector will be using the API calls or CLI modules that are usually giving you more information than the UI. Well, in that case, the AZ DevOps CLI doesn't give you a way to enumerate orphaned organizations. Up to this point, the only way we found to be able to enumerate those is by creating a new DevOps organization and then going to the Microsoft Entra and click the download button that you see here. This will download all the DevOps organizations that exist in your tenant. As you can see here, we have two. Up to this point, we didn't know that the RebelOps existed if we took the Anakin user as our starting point. So from an attacker's perspective, we found a new organization now that we were not able to see earlier. And we see also there is a URL over there. So in order to access each DevOps organization, you need to have the organization name and use that URL to see if you can access it. Well, we try to access it and we get a message that we don't have access. But this is weird because we are Azure DevOps administrators. We should have access, or at least, as you can see here, there is another button that says claim ownership. So how about we give ourselves owner on the organization? So clicking on that button, there's another pop-up and we can click on the claim ownership. That feature will only appear again if the organization doesn't have any active owners or collection administrators. So now, refreshing the previous page, we can see two organizations. The one that we already created and the RebelOps that was the orphan one. We see there is a project in the organization, so we're going to start looking a little bit on what that project does, how it's being used. Again, we need to start thinking as attackers, so in a real case environment, you see something, you need to dig into it to understand how it's being used by the environment and what is its actual business purpose, so you can blend in your attack vectors, your attacks, and try to be as stealth as possible. We see here that there is a service connection named DevOps Automations, and we see also that this DevOps Automation service principal has already a secret in the environment. So we're going to go through the source code of the application to understand how it works and see if we can leverage what we already know to extract that credentials and pivot to the Azure subscriptions. The first file we see is the backup.sh. The source code outlined here showcases how a backup job works. In particular, you provide a name, an argument, and that will be the name that the backup will have. Then it will pull an encryption key from a key vault, and last but not least, it will try to upload that backup that was created on a storage. And that means that probably the service principal has certain permissions that at least can read the key vault and make changes on a storage account. Looking on the YAML file for the pipeline, we see that there is a parameter with a default to null, and then we see a task, Azure CLI, and there is an Azure subscription area here that says DevOps Automation Service Connection. And this is the one that we saw earlier, the service connection that exists in the project. Then we have an inline script, and as you can see here, the backup sh script runs with a prefix on the name, but also the parameter that the user wants to provide. Now we need to look into the pipeline to understand the configurations and the settings. Apparently, the feature here that is off, the enable cell tasks arguments validation, is a default configuration on pipelines. So when you create a new pipeline, this is by default set to off. And this will let us execute additional arguments on the parameter we need to pass in the pipeline, potentially run arbitrary commands, interact with the agent, or even extract credentials. So the first case we're going to test is if we can actually run a simple command. We'll do an ls and a sudo -l to see what sudo privileges we have on the system. If we click on the run, the job will start, and as you can see here, interestingly enough, the file name parameter on the logs escapes the quote, so maybe our attack will not work. But going down the pipeline, it seems that it's actually working. The escaping is only happening on the file name and not when it actually executes the code. So we have two outputs here that we're interested in. The one is the ls command and the sudo. That seems we can do any command as a sudo, so we could potentially get root access on the agent. But we don't really care about the agent, we care about the service principal. Keep looking on the logs and the output, we can see that there is I think it's a bit blurry, hope you can see it. But here it says environmental variable and has a path, and also the login service principal. So that means the pipeline is actually using an enterprise application, a service principal, to perform some actions in the environment. We don't know yet what. So next we're going to see if we can print out the credentials. The service principal usually has a service principal ID and a service principal secret, which is equivalent to the password for the application. So print env and grab the service principal, hopefully will give us out something. The task completed, but as you can see, Microsoft has some protections in place. It gives some stars here, so unfortunately we cannot get the clear text value neither from the ID or the secret. But if we cannot get in clear text, how about we get it in base 64?
No way! Go that inside the shop, man.
Yeah. So we got the base 64, now the difficult part, decode it. So just a simple PowerShell script, we get the clear text values for the service principal ID and the key. We log in on the CLI, and as you can see here, we have authenticated with a service principal named DevOps Automations. Next step is to see what kind of privileges we have. Checking the assignments, we are listed as owner on a subscription. So I think this is as good as it gets. Now, those were the 4 scenarios. Hope you guys liked it. And then we're going to talk about the tool that we put together to enumerate and find those excessive privileges. The difficulty that we identified when we're trying to look into that is that when you go through the UI and the portal, there is no way to find the permissions of all the service principals. You need to go one by one, click on the service principal, click on the security, and then API permissions, and that will take ages if it's a big environment. So, AppHunter. It's a PowerShell tool. It searches for the overprivileged permissions. both in Entra ID and Azure resources, and it highlights whatever can be abused based on what we've seen. It's been designed for offensive operations to identify those privileges for red teamers and security researchers, but also for defenders, so they can fast identify those excessive privileges assigned on service principals.
Here's the demo.
A quick demo here. The one typing is Nikos, that's why it's slow. The authentication supports two methods, one for Graph and another one for Azure resources. So they use ARM is for the resources API.
We need to include something. The second method that we used include and Azure resources and with Graph API together.
Thank you, Nikos. So we do device code authentication.
Yeah, that's the reason we're doing again.
We're doing it the first time was for the Graph API, and the second is for the resources. If you skip that flag, you're only going to get a token for Entra ID, so you will not be able to run all the modules, but depending on how you want to run the tool, you can do that. So we're getting the access and refresh tokens, and then we have the enumeration modules, service principals, dangerous permissions. That will search to the service principal for API permissions that we consider dangerous. There is a predefined list on the tool that we're going to try to keep updating based on new trends and research. Usually those requests come back and the API calls come back with a lot of pages, so you need to go through all of those. And as you can see here, we have highlighted a few, the PAM manager that we talked earlier, permissions such as the AppRoleAssignment, and then we have the email protection that comes with the mail read write and mail read. The mail read write and mail read are not, usually they don't let you escalate privileges, but they can be used either for reading or deleting stuff from a mailbox and other attack vectors. Now we use the privilege role assignment, and that is for the for the Entra ID to check privilege roles. We saw that Nikos earlier made his service principal a global admin, so we need to change that back. And then we have the last module, which is the subscription owners and contributors. We focus on those two roles because those can cause most of the damage in environments, and we've seen them being used.
Can I burn all the Azure environment?
You can, yeah. So this was the demo for the tool.
Okay. So about now the detections and remediations that we suggest. As you already know that we are not in defense part, but we'll try to don't disappoint you. The first that we suggest is to focus on audit logs. Audit logs can be your guide according about service principals, configuration, if something changing, someone adds certificates, secrets. The second part, and according to Microsoft, is to create workbooks, and more specifically, sensitive operation report workbook, which will give you alerts about changing the changes about service principals. Fun fact, sensitive operation report nowadays it's only available to premium licenses according to Microsoft. Also, we suggest for DevOps to enable advanced security feature. And here are some recommendations according to the scenario that we present, because a lot of clients are coming to us, especially for the, let's take as example the first scenario with a custom owner, and they say what's the name? Sorry.
Service principal.
Yeah, the service principal, according to the company that it has the application, it suggests this permission. So if I don't have this permission, the application will not work. So we understand that it's very complicated, that we suggest to add any enterprise application owner and focuses as a high sensitive user. and monitor this user as high sensitive. Of course, for add conditional access policy and require multi-factor authentication inside in your company, outside of your internal network, doesn't matter. What else? We need to add something else?
I think that's
I think we're okay. Sorry. And questions?
Thank you. Thank you, everyone.
Thank you.